Hi everyone. Today we're going to study L'Hôpital's rule for 0 over 0 case. Consider the limit of quotient of two functions, such as the limit of f of x over g of x as x approaches a. If the limit of f of x as x approaches a equals L sub 1, and the limit of g of x as x approaches a equals L sub 2. And this L sub 2 is not equal to 0. The answer here is L sub 1 over L sub 2. However, if the limit of f of x as x approaches a equals 0, and the limit of g of x as x approaches a equals 0, we can write here 0 over 0. However, we call this now an indeterminate form of type 0 over 0. L'Hôpital's rule can now be used to evaluate limits of indeterminate form of this type. Take note that the notation 0 over 0 does not mean we are actually dividing 0 by 0. Rather, we are using the notation 0 over 0 to represent a quotient of limits, each of which is 0. Let's have the formal definition of L'Hôpital's rule. Suppose f and g are differentiable functions over an open interval containing a, except possibly at a. If the limit of f of x as x approaches a equals 0, and the limit of g of x as x approaches a equals 0, then the limit of f of x over g of x as x approaches a equals the limit of f prime of x over g prime of x as x approaches a. This formula here is now what we call the L'Hôpital's rule. Assuming the limit on the right exists, or is positive infinity, or negative infinity. This result also holds if we are considering one-sided limits, or if a equals positive infinity and negative infinity. Let us see this example. Evaluate each of the following limits by applying L'Hôpital's rule. We have three sample problems here. Let's begin with A. We have the limit of 1 minus cosine x over x as x approaches 0. We can see here that since the numerator 1 minus cosine x approaches 0 and the denominator x approaches 0, when x here is approaching 0. Thus, this is 0 over 0 case. We can apply L'Hôpital's rule to evaluate this limit. We copy first this problem here, and then, as per the L'Hôpital's rule, we're going to take the derivative of numerator over derivative of denominator. Derivative of 1 is 0. Derivative of negative cosine x is sine x over derivative of x is 1. Now let us take the limit of numerator over the limit of denominator. So the limit of sine x as x approaches 0 becomes 0. The limit of the constant 1 as x approaches 0 is 1. 0 over 1 is simply 0. This is our answer. So we're going to copy this answer opposite the problem A. Here we go. Let us have problem B. This is the limit of sine of pi x over ln x as x approaches 1. As x approaches 1, the numerator sine pi x approaches 0 and the denominator ln x approaches 0. Therefore, we can apply L'Hopital's rule. Let us copy this problem again, and then by L'Hopital's rule, we will take the derivative of numerator and denominator respectively. Let us now evaluate the corresponding derivatives. The derivative of sine pi x is pi cosine pi x over derivative of ln x is 1 over x. We can simplify this complex fraction into pi x cosine pi x. Now let us evaluate the limit. So we have now pi times this x becomes 1, and the cosine of pi is simply negative 1. Simplifying this further, we have negative pi. This is the final answer here. Let us copy this answer opposite problem B. Now problem C. The limit of e raised to 1 over x, then minus 1, all over x, as x approaches infinity. As x approaches infinity, the numerator e raised to 1 over x, then minus 1, approaches 0, and the denominator 1 over x approaches 0. Therefore, we can apply L'Hopital's rule. We copy again this problem here. By L'Hopital's rule, we will take the derivative of numerator over derivative of denominator. Evaluating the derivatives, we have now the numerator becomes e raised to 1 over x times negative 1 over x squared, all over derivative of 1 over x is negative 1 over x squared. We can see here that we can cancel this negative 1 over x squared respectively. So we simplify this expression now into limit of e raised to 1 over x as x approaches infinity. The 1 over x here becomes 1 over infinity, and it becomes 0. So e raised to 0 is simply 1. This is the answer. We copy this answer opposite problem C. Summarizing our answers, for problem A, it's 0. Problem B, negative pi. Problem C, 1. I hope you learned something from this video. See you again next time.